Okay, let's go ahead and get started with proving the business case for analytics with outcomes from the Smart Energy Analytics campaign. Next slide, please. I'm Jessica Granderson. If you've been to any of our past webinars, you'll recognize the faces of the campaign team, including Hannah Kramer, Eliot, Crowe, and Guanjing Lin. We're really glad you've joined today to hear the results of the 4-year Smart Energy Analytics campaign partnership. One note of housekeeping: if you have any questions during the presentation, you can submit them through the questions box. We'd suggest that you get those in early. We don't always have time to get through all of the questions we receive, and there's a lot of attendees on the webinar today. Next slide. We're very excited to share with you our final findings. These are now published and publicly available in the report, Proving the Business Case for Building Analytics. That's complemented by the EMIS Applications Showcase, which shines a light on many of our award-winning campaign participants and their best practices in installing and using EMIS technologies. We also created an infographic to visually explain and summarize the value proposition for technology adoption. It's through the great work of so many campaign participants that we've built the strongest evidence base ever that analytics enable deep savings with rapid payback. And we hope that this body of work drives confidence for much broader scale adoption throughout the commercial sector. Next slide, please. I'd also like to direct you to check out our newly revamped Smart Energy Analytics campaign website. It's a great place to learn about the results of the work and provides links to the 3 resources I showed on the previous slide. We hope you'll visit this site yourselves and share it with your colleagues. Now, I want to reiterate our thanks and our recognition of everyone who participated in the campaign. Your efforts to share knowledge and to provide data for the research have really resulted in a tremendous contribution to our field. And I want to also acknowledge Cedar Blazik and Amy Harone at DOE's Building Technologies Office for their support of this work and for their direction throughout its duration. Now I'll turn it over to Hannah to cover a brief overview of EMIS technologies, followed by detailed outcomes from the campaign.
Thanks so much, Jessica. So, Energy Management and Information Systems, EMIS. We're going to give a quick overview. Many of you have seen this before, but we have this updated graphic now that really helps try to describe these 3 areas of EMIS. So, EMIS can bring in a variety of data sources. Most common are utility bills, interval meters, weather data, building automation system data. And all this data is brought into a database using various drivers or connectors, and then the applications lay on top of that. So the EMIS capabilities may have different applications, such as monthly data analytics, energy information systems that use interval data to do analytics, and also for advanced M&V, and then fault detection and diagnostics and automated system optimization. So these 4 applications and EMIS capabilities are not included in every EMIS. Many EMIS started with a certain area of focus, and then they may have broadened to include multiple areas of focus. So a single product may include multiple capabilities. And we're going to look at these capabilities more in a minute. But overall, EMIS takes a whole lot of data and helps make it understandable and actionable. I'm sure you all have had the challenges of managing data overload, and that's the intent of EMIS, is not to make that worse, but to make that better. So in the Smart Energy Analytics campaign, we focused on moving owners toward deeper levels of EMIS, so beyond the monthly data, monthly bills, and into interval data and the capabilities of EIS, FDD, and ASL. Next slide, please. We also have a new graphic that describes how EMIS tools are used in action. Tools are only as good as a process in place to get use out of them. So in other words, the tool itself doesn't generate the savings, it's how it's used. I think we all have that grounding in, how we use the tools and in our energy management processes, and potentially in our monitoring-based commissioning process is really important. You may have heard of this monitoring-based commissioning term before. It's this process of really reviewing building performance in an ongoing fashion and using the EMIS to make that possible. So EMIS can be used in ways to support any energy management program. It doesn't have to be MBCX. I just wanted to make that clear. So this graphic here really describes, the data collection piece, which we talked about just a bit, any sensors, meters, now getting into IoT devices, building automation system data. You organize that data, you perform analytics on it that transforms it into actionable data. Now it's sort of outside of the tool, you implement stuff, you look at the analytics, you make repairs or improvements. Sometimes the tools can directly do that themselves as an ASO, which we'll talk about in a second. And then you monitor and track improvements over time and measure the savings. So this is a continuous process where you're kind of peeling the layers of the onion, you're finding more and more things over time, and you're making sure things you fixed stay fixed. Next slide, please. So I'm going to give a few visuals of what we're talking about here. There's countless types of charts, lots of flexibility within energy information system. Basically, what we're trying to do is look at whole building or sub-meter level data, visualize, maybe summarize the data in ways that you couldn't do very easily without these types of tools. In terms of M&V using a baseline interval data model and so forth. So on the left here, you'll see a heat map, which shows a low demand in green and high demand in red. Heat maps are really a popular way to visualize and flag issues with schedules and off-hours usage. You'll see a big green area on this graph. This is a college, and that was, before they were in session, and you'll see red kind of really late at night, which shows the kids studying all night. So that looks a lot different than an office. In the middle, we have a calendar view that is color-coded to show days with high energy use relative to a modeled baseline prediction. So here you don't just take a gut sense of, oh, I think my energy use is okay because it was hot today. This is factored in. You can have a weather normalized prediction based on your baseline energy use and then compare that to your actual daily use across the 24-hour load shape. And then on the right, we have a real-time load shape at the top. So you see the blue line with the green band around it. The green band is a predicted load, and that lets sort of the operators know kind of how they're doing relative to their real-time operation. So in a nutshell, there's a lot of different ways to look at it. In the campaign toolkit, which I'll point to in just a few slides, we have a 3-part webinar series that gets into lots more detail. Next slide, please. So now on to fault detection and diagnostics. These types of tools flag faults based on expert rule sets, pattern recognition, other methods. Now it's starting to get into machine learning methods. So the software continuously runs the diagnostics, detects issues, and provides recommendations for diagnosing the problem. So here are some visuals. In the upper left, we have the duration of fault indicated by the colored bars. That's a pretty typical view of faults. The middle shows an example of like drilling into a particular fault and the suggested actions around that particular fault. The upper right is a type of plot that is kind of a diagnostic plot within FDD tools that some FDD tools focus on. It helps the operator see, in this case, which zones the supply air dampers are flat out open, like the red bar there is that a zone where it's 100% open all the time, or whether it's oscillating open and closed. And these types of things can really help support those fault summaries that are available in the tools. Most of these tools have methods for prioritizing faults, which is important because they find a lot of faults. Okay, next slide, please. And then finally, automated system optimization. These types of tools differ from fault detection in that there's two-way communication with the control system. So ASO tools dynamically modify the BIS, the control settings to optimize across systems in using predictive controls generally while maintaining that occupant comfort. So in this case, this tool focuses on optimizing chilled water plant and air handler reset strategies based on outdoor conditions. There can also be other ways, other objectives of the control functions like minimizing oscillations and so forth. So ASO is a supervisory control in general, and it can use more sophisticated control techniques than are typically available in building automation systems. Next slide. So I went pretty quickly on purpose because a lot of you already know the basics. I want to talk next about the different avenues for service provider support of owners and building engineers. So we have these kind of three phases here. We have EMIS installation and commissioning. Generally service providers or the tool vendors themselves are going to be installing the software, getting it up and running, checking data quality, all these kinds of things. This isn't something that owners are responsible for. It takes a very specific skill set that knows their tools well. The next step is ongoing EMIS data review. That might be a step that internally is handed over to the building operations team, or it might be sort of a collaborative effort between a service provider and the building operations team. So that could be an additional monitoring-based commissioning service an owner might choose to purchase from a service provider. And then finally, there's this corrective action and verification phase. The ongoing EMIS data review is all remote. The corrective action and verification would be like actually going on site, supporting the operators in finding and fixing issues and verifying the correction. So that's just another layer deeper of having support to the operations staff in using the software. Next slide. So we've covered the basics of monitoring-based commissioning and EMIS. The Smart Energy Analytics campaign, for those that weren't aware of it before, was intended to catalyze adoption of EMIS, provide technical assistance for participants to maximize benefit, and build evidence to inspire market uptake. So we had a 4-year program where we worked with owners, and we got 104 organizations, most all portfolio on board, covered a lot of different market sectors. And we wanted to provide cost savings and EMIS use metrics that weren't really available to the public before. So here's the high-level results in this infographic here. Going to 3% savings for folks that had implemented EIS and 9% for FDD, with an overall simple payback on the investment of about 2 years. I also wanted to note here that the study didn't just cover like a few vendors' products. We had these 104 organizations, and I counted it up, and we had 40 different vendors that are represented in this report. Most of them are, commercial vendors that, sell their products, and some are in-house developed EMIS as well. We calculated savings for each portfolio that shared data with us, and the median portfolio of 15 million square feet. So this gives about the size. There's, some really big portfolios involved here, saved an estimated $3 million per year. And then if everyone in the campaign, so all these 104 organizations, was completed in their implementation of EMIS, we had about 20% that were in progress, the total savings would have been $95 million per year once they're all on board. Next slide, please. So I want to orient you to how things have changed if you're familiar with the old Smart Energy Analytics campaign website. The new website is this website, the blue one on the right side there. It's the same address, and it really focuses on, telling the story of the campaign, what the results were. It gives all the different reports and infographic and so forth available through that website. So that's a nice place to go to get an overview of the results. But if you want all the tools and templates and information, next slide please, that you had available prior, that has been moved to the Better Building Solution Center. We have this thing called the Smart Energy Analytics Campaign Toolkit. So this is where it's going to be housed going forward. All those tools and templates are now organized here and you can access them. Next slide, please. All right, so now to the actual campaign report findings. Next slide. Here's our breakdown. We have mostly office and higher ed, but healthcare has really come on strong towards the past few years. The most common total size of participating organization was between 1 and 5 million square feet. And so this was lots of times, multiple buildings on a campus or a national portfolio of buildings. And we also had a few single sites during the campaign that were under 100,000 square feet each. On the donut chart on the right, like I mentioned before, we had, you'll see it says N equals 85 because we had 19 organizations that had not yet installed their system, so they're not included on Figure 5. And they were in the process of writing the RFP or getting started and getting their funding. 73% of organizations then had an EIS, as we talked about before, using that interval data to analyze whole building or submeters, and 61% are implementing FDD for their HVAC systems. So the participant, I'm going to explain this EIS plus FDD piece of the pie here. Many folks had a combination of EIS and FDD, which is represented there. But really, if you looked at what those installations were, they were mostly a single software package that primarily focused on FDD and had some whole building meter analysis, but it really wasn't the focus of the tool. Just a few owners had separate EIS and FDD software installed. So when we come to looking at all the costs and savings data for EIS and FDD, we lumped the FDD and the EIS plus FDD into a group and called that FDD for the purposes of that analysis because it really was a primarily FDD tool. And ASO, you'll see, is a very small piece of the pie right now. It's not very prevalent in the market. We don't report cost and savings for ASO for this reason, but we did have a few people who are getting really great value out of it. Next slide. We asked owners and organizations the benefits of implementing the EMIS. I'm not going to spend too much time on these. Energy savings was a common driver, occupant comfort, improved operations were additional benefits. The thing I wanted to stress from here is that the EMIS was really seen as a benefit for informing retrofits as well and validating project savings. So having a better view into how your systems are operating and even like what's my actual load versus what I thought it was, what does it look like over time can really help you appropriately size a retrofit. Next slide, please. The top measures, we asked owners what they implemented with the support of their EMIS, and this has been really consistent year to year. We keep asking all the new participants what this is for them. You'll see a full list of the top measures in the final report. Here we have the top 14. So you'll notice that this is the same list of measures as you'll typically find in existing building commissioning. Only these organizations are using their EMIS to help them find these opportunities. So, we ranged from scheduling issues. EMIS helps them detect those issues more quickly. And set points and reset schedules are also really common. So these findings really were consistent across all market sectors in our data set. And even from the first year we got this data and, we had increased amount year to year, they were very consistent as we went into year 4 in the final numbers. Next slide, please. And you'll see in these slides, I should mention that it shows figure numbers. That's because these are taken from our final report, which is published directly on the campaign website. So this is the explanation of all the figures you'll see in that report. These graphs are really some key findings from energy savings. I'll just explain the axes here. This shows the energy use for each year after EMIS was installed relative to the energy use in the year prior to EMIS installation. So year 2 would be the energy use in year 2 relative to the baseline year of the year prior to EMIS installation. The gray lines represent average savings from the buildings with EMIS in an organization. So each gray line is a portfolio of buildings. The red line is a median savings among those portfolios. So this is also for organizations that provided us energy data. Not every organization in the campaign was able to do that. And our median portfolio size for EIS was about 2 million square feet, and FDD was about 1 million square feet. So you get a sense of kind of how many square feet each of these gray lines are representing. And of course, you'll see the trajectory is up. For EIS, it's fairly flat, goes up later. The flatness is basically related to a couple of negative savings. We always get questions about the negative savings. We don't go back and say, what was going on? And we just take their actual data. Sometimes their campus has, increased energy use because they added some buildings to the portfolio, and we can't always kind of tease all that out. So we felt like taking median with the amount of data we had was a good indicator of understanding the trajectory of savings. Next slide, please. I'll also note that we didn't isolate savings due to EMIS versus other interventions. We simply looked, EMIS is a tool. You can't just isolate the savings from that tool. We looked at energy savings since the EMIS was implemented, and there could be other things going on there. In general, we felt like, the amount of time and energy it takes to implement an EIS or FDD, within that first year or two, they're probably not also doing a whole lot of other major projects. So in the out years, we might see savings increasing over time due to other things. And maybe the savings might all be from EMIS, or there might have been some retrofits in those cases. So we're talking about, in the next slide I'll talk about, we're picking year 2 savings as a good indicator of the savings from EMIS, and those out years are potentially from other things. We even hesitated to show these out years in the long-term charts of changes because we don't want folks to start citing LBNL results of like 13 to 27% for FDD savings. That's not what we're saying. We're saying 9% for FDD. So we can say that organizations that have EMIS see large reductions in energy use from a combination of their activities. And again, we're looking at second-year savings as a reasonable estimate of the savings kind of relative to mostly the operational improvements. Next slide.
Hey, Hannah, this is Eliot, and I'm just taking a look at the questions coming in here and holding them till the end, but just had a couple of questions I thought might be worth throwing in here. A couple of people asking about weather variability and how that might be factored into the savings estimates. So I wonder if you can just very briefly touch on that.
Of course, yeah. So when we were able to get weather normalized data already from the owner, we used that weather normalized data. I would say it was in probably about half the cases. If it hadn't already been weather normalized, then we just used raw data. So it's kind of a mix. And yeah, so this is the trajectory is kind of what you look at. All right, so we have second-year savings of 3% median whole building energy savings for EIS and three times that savings for FDD. It's not surprising that we see higher savings for FDD because It has that detailed measure identification involved. It pinpoints issues more specifically than EIS. And EIS is really intended to be this big picture tool for detecting changes in meter level energy use. You can see your peak loads, you can see your base load, overnight usage schedules, morning ramp up, all those types of things, which actually are super important and oftentimes the first step to an energy management program, and then getting more detailed in FDD. So these tools really do complement each other. And we'll also see that in a few slides that, EIS may have less savings, but the cost is also much lower than FDD. I'll just mention here, for the year 2, the median portfolio size for EIS was about 3 million square feet, and for FDD was about 1 million square feet. Next slide. Cost data. We're going to go pretty quickly through costs. There's a lot of data on cost. I want to give a little bit of grounding in the size of the portfolios for our cost data specifically. We have the median portfolio size larger for EIS. We see that EIS tends to be implemented on larger portfolios, which makes sense because it requires less data per building, so it's kind of easier to implement on a large portfolio. And the buildings themselves tend to be larger for FDD installations because of the economies of scale of the HVAC system types in large buildings. FDD vendors focus on salts for built-up systems. So the costs are normalized by gross floor area. So it is important to think about portfolio size when looking at these per square foot costs that I'm going to give you medians for in just a second here. When you look across the portfolio sizes, EIS costs are fairly consistent from small to large portfolios. The FDD costs tended to be higher for smaller buildings and portfolios, which makes sense with all those base costs involved in implementing the system. And cost per square foot tends to be higher for pilots. It's fewer buildings, fewer square foot, and so the cost per square foot increase. Next slide, please. So we're going to start with base cost. We have costs on base cost of installation, recurring EMIS cost, and the time in-house staff spends using and responding to analytics. And just a reminder here that these costs don't include the measure implementation costs, which we include that estimate in our payback calculations, which I'll cover later. But these are just the costs of the EMIS software installation, configuration, including the EMIS vendor and service provider costs. They don't include costs of energy metering hardware and communications, adding points to the BAS and retrofits and so forth. All that detail and methodology is in the report. So we have the median EIS base cost at 1 cent per square foot, the median FDD at 6 cents per square foot. And, FDD has a greater variation in the cost for base costs. And again, the smaller sites tended to be the ones with higher per square foot costs, or they were pilot sites. Next slide, please. Recurring costs. This mostly consists of annual software as a service fees, and for sites with monitoring-based commissioning service providers, so people helping support the use of the tool, we also lumped that into the EMIS recurring cost. They're much lower than base cost. Well, they're the same for EIS, but much lower for FDD. And there's less variability in the costs. It's a little more consistent across all the data we brought in. Next slide, please. So this slide summarizes our cost by EMIS type. We did the per square foot cost, which we've talked about now, but we also looked at it at per point and per building. The EIS cost per point in this case per meter is about $400, and the recurring cost is $150 per meter. This doesn't include the cost of the meter itself. Again, it's the cost to integrate the existing meters and configure the EIS software. We, on average, saw about 4 meters per building connected to the EIS. The cost per point for FDD are really low because typically we see almost 2,000 BAS points per building are integrated. And the median cost to implement FDD is a lot higher, obviously, than the cost to implement EIS. The median building size is also higher, is larger for FDD than EIS, which we've talked about. This gives us a summary. I think we'll go on to the next one in the interest of time. The last area of cost we looked at was in-house labor resource requirements for EMIS use. So we asked owners, how much time do you spend per month for ongoing EMIS interaction, like looking at the data, figuring out what to do with the analytics? And in general, we saw about an hour a month per building for EIS and 9 hours per month per building for FDD. The higher cost is mostly a good thing, actually, because it means that the owner was really utilizing their EMIS and gaining value from it. And it's not surprising that owners are spending more time with their FDD software than their EIS software with the complexity of the recommendations. Next slide, please. So we calculated simple payback for participants in which we had both savings and cost data. We have 24 organizations shown here. The cost side, we used the base EMIS software and installation costs. We used recurring costs for 2 years and an estimate for cost to implement operational measures. So we wanted to make sure we covered the cost it would take to actually install all the measures found through the EMIS. And then we divided that by second year energy cost savings. The outliers here for the FDD, going back and looking at what was going on at those places, those are really places that had just implemented their systems. They hadn't really fully integrated what they were doing with their operations. So they had all the cost side, but they hadn't kind of had a chance to accumulate the benefit side of it yet. So I kind of consider the 25-year, 15-year outliers. And more than 2 years payback is actually good news. We didn't know what it would be when we started this and gathering the data. So 2 years seems pretty reasonable. Next slide, please. All right, so a few industry trends, and then I'm going to turn it over to Eliot to talk about the EMIS showcase for a minute here. On the product side, we're seeing a lot more EIS and FDD capabilities in a single software. There are over 100 EMIS that we kind of cataloged in the market. The majority were EIS or had EIS capabilities, about 30% FDD and 10% ASO. And one of the advancements we kind of saw over the last 4 years was better prioritization views. This is an issue for owners trying to make sure they're not bogged down in the number of faults and analytics provided. So, some MBCX service providers really specialize in that prioritization process. Kind of a side trend is machine learning. You're starting to see a lot of talk about that beginning to be used for data tagging, load prediction, and control optimization. I'll just give a plug for a recent machine learning presentation that Jessica gave on the subject that was really great to ground us in how machine learning is being used in EMIS. And then maintenance management systems integration, that's where you're connecting the faults into your CMMS, and that's really, in the early stages. Some of the folks that are really bought in and want to integrate it with all their existing systems are seeing a lot of great benefits of that, of having a single system for tracking the measures. But it's kind of, I think, on the earlier adoption side, as is the automated M&V using those baseline models for whole building M&V. The tools have it. The tools are ready to use it. The owners don't seem to be using it as much as they could be. Next slide, please. And then we have MBCX services trends. New opportunities really for commissioning firms and service providers that are looking to provide ongoing support and using EMIS and helping owners over time. I'll mention that, retro commissioning is great, and may be used as a first step prior to EMIS installation, or it can be used as like the EMIS can be used as a tool during the retrocommissioning process to make trend analysis easier and maybe make the retrocommissioning more comprehensive amongst all the zone analysis. So either way, there's a transition from a periodic retrocommissioning, which is about every 5 years, to this ongoing MBCX and making sure that measures corrected persist. This is a big change in the industry. It's going to take a while to really happen, but it's a real opportunity for service providers to have an ongoing relationship and help owners keep those savings consistent over time. All right, so next slide, I'm going to turn it over to Eliot Crowe to talk about our brand new EMIS applications showcase that we're really excited about.
Thanks, Hannah. Outstanding job on timekeeping there. You must have Jedi skills. This is exactly where I hoped you'd hand off to me. So a key element of the campaign was giving recognition for outstanding examples of EMIS installations. Through the campaign over the 4 years, we recognized 32 organizations across several categories. And for most of these, we developed 2-page success stories. On the slide here on the right-hand side, you'll see an example of one of those success stories, and they're all available for download right now. As the campaign was wrapping up, we decided to step back and consider what are the key themes that really come through from all of these award-winning organizations, and decided to develop this showcase document to highlight those themes. It's somewhere between a case study, a report, and a best practice guide, but above all, it highlights the range of strategies being successfully deployed today by some of these leading organizations across many market segments. And very happy to see some familiar names from these organizations in the attendee list, so kudos to all of you. The themes in the showcase are grouped into 3 sections: getting started, best practices, and innovation. I'm going to cover a slide on each of those. If we can go to the next slide here. I will not try to cover all of the content, but for each of the 3 sections, try to just maybe give you a taste with a couple of examples, and hopefully that's enough to have you dive into the document and take a look deeper. So, getting started with EMIS can be a pretty daunting undertaking. This slide is showing the elements that are highlighted in the showcase. And so a couple of examples. So one, starting out with a pilot can help you work out the kinks, as University of Utah Health learned. They worked with a third-party engineering firm to get FDD rolling in a single building on their campus, and that helped them determine how the tool would mesh with their internal energy management processes. They did that. They also achieved 10% energy savings after a year of using that tool, and then they started working on adding another 12 buildings to that tool from that foundation. Another way to take the first step is to focus on a very specific goal. Clyde's Properties is an example of that. They saw their electric demand charges had almost doubled. So they focused on that specific aspect and that specific goal when they started using their EIS. They saw, again, very rapid savings, about $17,000 in reduction in the first quarter after they implemented their EIS. And then from there, they worked on expanding their analytics, both looking at other goals and also looking to add some of the FDD capabilities that that tool had. Next slide, please. Next up, best practices. As Hannah had mentioned at least once, applying a structured monitoring-based commissioning program is a strongly recommended best practice. California State University Dominguez Hills saved $100,000 from the first wave of their MBCX efforts. They continued from there to go even deeper and get another $100,000 of savings in a second wave. And then they obviously have their FDD tool then to help maintain those savings and go deeper over time. Kaiser Permanente is a great example of an organization that's leveraging their EMIS to maintain management support. So they're pulling data from their EMIS into a custom reporting dashboard, which tracks their FDD rollout across their portfolio. They can track engagement at site level staff level. And they can also track the bottom line impacts in terms of the number of improvements that are being implemented, the actual energy savings and cost savings that comes from that. And that's a really powerful tool for ensuring that upper management are supportive of the continued investment in building analytics. That is a big theme here, that once you've installed it and got the savings, you really need to make sure that people are convinced to keep investing, to go deeper, to maintain the staff support and also the subscription fees. Next slide, please. Now, when starting out with an EMIS, you're likely to pick the low-hanging fruit first. So looking at improving equipment scheduling, fixing common controls issues, etc. But then there's a whole world of fun beyond that. University of California, Davis integrated their EMIS with a custom-designed occupant engagement platform that gives user-friendly visualization of energy use across their campus. And as shown on the screen here, they developed a platform for users to communicate whether they're too hot or too cold. And being integrated with the EMIS, they can then drill down deeper to those buildings that have the biggest hot and cold call lists to find out what's actually going on there through their FDD and EAS tools. Another innovation example is Pomona College, where they are monitoring Wi-Fi connections as a proxy for building occupancy. Now, getting a good gauge on real-time building occupancy can be really helpful in optimizing control strategies, and counting the number of Wi-Fi connections is a good way to do that while avoiding data privacy issues, because you're not monitoring the actual traffic, you're not monitoring who is connected, simply the number of connections to the Wi-Fi in a given building. Next slide, please. Now here we see a snapshot of all the organizations that we recognized under the campaign. And you know, it's interesting, 10 years ago, I was working on getting together some analytics case studies for the California Commissioning Collaborative. Hannah and I, I'm sure you remember that too. You know, they were hard to find. We ended up with 4 case studies. By the time we'd actually written up the case studies, one of the organizations had actually stopped using analytics. And boy, things have changed. It's been so encouraging through this campaign to see so many organizations doing this good work, integrating analytics into their daily management practices across many sectors nationwide. You know, it's been a really fantastic privilege, really, to see what people are doing with their tools and to see the market reaching maturity and the level of innovation that's happening there across the commercial sector. And if you take a look in the showcase, you'll be able to take a look at those examples and hopefully cite them as examples of business as usual analytics. With that, we'll go to the next slide and I'll hand it back to Hannah.
Thanks, Eliot. And I do encourage you to go look at the showcase. Eliot wrote it. It's really great. He's a little humble about it, but it's a lot of good stuff in there. Quickly, just what's here on the campaign toolkit. This is just how we organize the stuff that used to be on the Smart Energy Analytics campaign. Just wanted to, you can see that on the Better Buildings website. Next slide, please. We have templates and examples you may or may not have known about on the website. We have an EMIS specification and procurement support materials. This is RFP templates. So if you're specifying your system, it's a template where you can cut things out as you need to. So it's customizable. It gives you good base language to use and start from there and customize it to your situation. We're just finishing up a big update to this where we added a service section to it. So it's not just specifying the tool, but it's specifying the range of MBCX services. So we'll be sharing when that comes out. To make that spec, we also, and to update it, we asked for example RFPs from across a number of campaign participants. We anonymized those RFPs and we have them here in the middle. It's also on the Better Buildings website. So this is a really good place to look at, oh, these folks were trying to do X, Y, and Z as their objectives, and this is what their RFP looked like. So you can take a look at examples there. And then we also created a monitoring-based commissioning plan template to help you create your plan for what you want to put in your MBCX program. Next slide. And ongoing, just because the campaign is over doesn't mean that there aren't opportunities for more technical support and resources from the lab. We have, of course, these access to templates. We can help you get started, and let us know if you have questions on how to use the templates. We want them to be useful, and we're definitely happy to help you get started. These results are not just for owners; they're for utilities, other policymakers, and incorporating to enhance, performance tracking, supplement disclosure initiatives, and also state and regional energy offices can leverage to, expand their commissioning and operational programs. On the building owners, managers, and operators side of things, you can join the EMIS tech team. Actually, anyone can join the EMIS tech team. I'll give you the email. You can email me, and I'll make sure you get on the list. That means you get invited to all these webinars. We're going to have one coming up on COVID and FDD. We're going to have another coming up on IoT as related to EMIS. And then if you're a Better Buildings Alliance member, which is something you commit to through Better Buildings, we'll give you a little bit more technical support than just being on the EMIS tech team. So we encourage you to sign up as an Alliance member. Next slide, please. So with that, the takeaways from this is really we're in this kind of call to action phase where we have all this information. We have an extensive set of examples. We have this business case. We've seen it in the past 20 years from very early adopter phase to really quite prevalent in the industry and gaining momentum. And, owners are finding savings. They're using ongoing analytics and moving from kind of a reactive mode to a proactive mode. So having such a broad range of EMIS represented in the campaign, I can say that it's not the EMIS you choose, it's how you use it and how systematically you use it in your operating practices, and we have a lot of success stories to show that. So now that the study results are available, we really hope you use this information to help develop your own business case and work to expand the use of building analytics. So I'm going to leave it here for the Q&A portion, and Eliot's been gathering the questions. We have about 10 minutes for questions.
Yeah, thanks, Hannah. Some great questions coming in, and there will be some more time, I'm sure. So if others have questions, please send them in here. I had a couple of questions that are somewhat connected. The first is about the idea of either utilities or energy metering systems actually reporting energy savings rather than energy use. And the follow-on was kind of talking about if that's the way that an accounting department of an organization can monitor things, that they don't monitor the bills, so they monitor what their savings are. I was wondering if you have any comments on that, on how that's kind of being adopted either by utilities or how it's showing up in organizations.
Yeah, so looking at energy savings at the whole building level is really kind of at the forefront of whole building programs, both for utilities and for owners and operators. So instead of measuring savings from each individual retrofit or each individual measure, we're looking at overall, how does it all interact and roll up to the whole building level? And you can do that through these models of a baseline, and you project that baseline into the current period, and you subtract relative to the actual energy use. So it's weather normalized. You can normalize for occupancy changes. You can do non-routine adjustments relative to COVID and things like that. So your question around like measuring savings versus usage, definitely you need to measure usage because you're paying on those numbers. On savings, it's really kind of the next generation of making sure your savings persist. You could measure savings after a retrocommissioning project and then make sure you keep those savings or increase those savings over time, and kind of keep track of that all through your MD with your energy management information system. So I think it's definitely a tool that needs to be used more. And setting up those baselines is important, in knowing when to reset the baseline if things have changed in your building. Those are all like the nitty-gritty details that we can talk about with owners and help them with that.
Thanks, Hannah. You mentioned COVID in that last response. There's another question here about how can EMIS tools help to address changes that are due to COVID?
Yeah, so there's the opportunity to help address pandemic mode operations by flagging issues related to things that we care about with COVID. So airflow, static pressure, making sure we're getting air to the most remote zone, outdoor air percentage. If you're achieving comfortable conditions when you have all this excess outside air, all these things are really things that are hard to monitor without the software monitoring it for you and really helping you address whether you're achieving those really important things for a healthy building. So the FDD system especially can really help you pinpoint maybe which zones are not really achieving those, maybe when your outside air fraction isn't what you want it to be, when your new filters are giving you a lot more pressure drop than you're used to because they're MERV 13, and then you're trying to operate your system adequately. So it can help you, having the monitoring in place can really help operations team proactively manage and feel confident about their COVID operations.
Thanks. Next question, I'll maybe paraphrase and broaden it a little bit. So someone was asking about resources for correctly specifying EMIS in new construction. Maybe you can talk more broadly about just resources for specifying EMIS as well as specifically for new construction.
Yeah. New construction is a great place to get it all in place, especially on the metering side, to make sure you're grouping end uses together so you can look at your lighting load, your plug load, and your HVAC load separately without getting all mixed up in all the different circuits. So it's a great time to do it. I think you can look at the RFP template that we have as something to help specify even from the beginning, not on existing systems. You can modify it to put in your new construction specifications. And we're seeing more and more, and even with retrofits, just kind of folding in the EMIS implementation as a part of that, because on a really large scale project like new construction or a major retrofit, adding EMIS is not the largest cost in the world compared to that project. So it's really an opportunity to get the monitoring in place you want to then operate going forward efficiently.
Great. I'll tack onto that. Just one of the success stories was for Salt Lake City, and they didn't have EMIS within their new construction process, but they had a newly constructed building that was designed to be net zero carbon, did not achieve that until FDD was applied to address some issues on the natural gas consumption specifically. And that maybe points to some justification for adding EMIS during new construction. I think to address those things up front would be certainly helpful. Next comment, again, I'll paraphrase this a little bit. We had a question that was speaking to your data, Hannah, on staff cost for operating EMIS and labor hours, etc. And it kind of just to maybe expand on the theme a little bit about the extent to which the effort by the operators is just kind of doing their day job versus whether it's actually overtime that has a specific added cost for an organization. Just wonder if you can speak more broadly to the theme of how much extra effort do you think EMIS brings?
Yeah, so I think initially there is some extra effort to get things up and running, to get through that initial fault list in the case of FDD. It is generally then a part of someone's existing job. You don't in some cases, people hired an extra person to be kind of the guru of the FDD system and be on point for all that. But as it becomes more proactive over time, we had a really great case study of hot and cold calls actually drastically decreasing after the FDD had been implemented for a year or two, because things are being fixed before there's hot and cold calls to fix them. So some of this cost isn't really additional cost because it's already the same staff you're using them more efficiently, they're getting better tools, and in our cost, our payback calculations, we're trying to be really conservative. So we're trying to account for all the costs, even if it might have been a little, part of existing costs, and making sure that we had covered the measure implementation.
Great, thanks, Hannah. Okay, so there's a question here about whole building meters versus sub-meters, and how prevalent is the EAS sub-metering, and does that lead to better or more insightful results?
Yeah, it's a good question. We mostly saw whole building metering. There was some tenant level sub-metering, but not on an end use perspective very much. So people didn't have their lighting loads segregated, plug loads, for instance. So it was pretty much like getting the big picture of what's happening in their building. There were a few cases where there was a very deep end use metering and down to the circuit level, and that takes a lot of horsepower to organize all that data and know what you're looking at with that many meters. So I guess I don't think we have enough data to say if you had sub-meters, it would give you this much more savings. Most of our data was the big picture.
Great, thanks. And again, tying that to a success story, I know that the Franklin building in Chicago is one example where they did get great results from sub-metering. Maybe just one last, you know what, it's 10:59. I should probably hand off to wrap things up, Hannah. I don't know if you have some closing comments here.
Sure, thank you. All right, so next slide, please. I want to give a plug for our next webinar. We hope you'll join us for the FDD in the age of COVID-19. David Landman is going to be talking about, what happens to FDD when the building goes into COVID-19 operation. What does it do to existing algorithms? What are new algorithms that can be implemented? So please register for that. You'll get this deck and you can press that link to register. Next slide. And I'll just end by, I appreciate your great questions today, and please do reach out a number of different ways. If you're an owner, operator, or manager, and you want to join the Better Buildings Alliance, you can, there's a web form there to click join, or contact the Better Buildings Alliance and get more information at that email address there. And then if you want to make sure that you're on the email list to get all these webinars, if you're not sure you are already, just give me an email. And if you have any additional questions that we didn't get to, make sure, feel free to email me with that. We're on the hour here. I appreciate it. We made it through all the content, and we have all this great new final material, and we're really excited to get the word out. So if you have other ideas on how you can help us get the word out, please do reach out as well, and we'll be happy to work with you. Thanks so much, and have a great afternoon.